Hello. Today's video is going to cover the level of measurement assignment. As you can see on your screen here, this is a edited version of the assignment that has instruction and explanation on it. I'll be posting this along with the video, so you'll be able to review both the video and uh, the explanation version of the assignment. So this assignment covers level of measurement. I want you to pay particular attention first to the explanation uh, because the information provided in this paragraph here is full of information that you'll need to complete the assignment. You're looking at information here that says the data was gathered by intake officers from various sources. Victimization likelihood is the intake officer's perception of the likelihood that this offender will be victimized while incarcerated. So that gives us a hint to the dependent variable, as does, of course, the research question. What inmate characteristics influence the Indiana Department of Corrections perception of inmates' victimization risk? So we know here by this statement and what we've covered previously with the last assignment is victimization risk or victimization likelihood is in fact the dependent variable. Also, we have here an explanation or the scoring on that particular variable, the victimization likelihood. 1 being not likely, 2 being an increased risk, and 3 likely needs protective custody. So if we go down here, we see that prisoner ID or prison inmate 634102 has a not likely, it's been scored a not likely to be a victim while in the institution. While on the other hand, 64913 appears to have a high likelihood and will need to be in protective custody. So that is what the 1, 2, and the 3 designate within this particular variable. So I refer back to the PowerPoint here in Chapter 5. It starts on number 6, the level of measurements. And we go through 4 levels of measurement, and you can think of them as to the lowest level of measurement to the highest level of measurement. We have nominal, ordinal, interval, and ratio. Now, as you read the book and have reviewed these PowerPoints, we know that nominal measures and the variables do not have any mathematical property attached to it. So if we go back to the assignment, you'll see here that prison ID. That is a nominal level variable. The prison ID number is a number that just designates an individual's name. Much like your Ball State student ID, that ID number just designates the name. There is no mathematical property to that particular number. Same with zip codes or social security numbers. On the other hand, we have a variable here, race, and you see 1s and 0s. Well, you don't know what the 1s or 0s designate. In fact, I can tell you that the 1 designates a person that is non-white, and 0 designates a person who is white. These are common coded variables in criminological research, and it's just an effort to what we say control for one's particular race. But you cannot rank order them. It's just a designation of an individual's race. So that's important to remember that the 1 and the 0 have no mathematical property. But when you're completing statistical analysis, which of course is beyond the scope of this particular class, but when you are completing statistical analysis or mathematical equations, everything needs to be in number form. So that is why we have number form for nominal level variables. And so you're just asking yourself, can I rank order these? Do they have a mathematical property when you're thinking about particular variables? Let's go to the examples. So you have male, female. Of course, can't rank order, but in a data set, you would have one designated as 0, one designated as 1. It doesn't matter for our purposes which one is designated with which number. It's really for interpretation purposes, again, through statistical analysis. So let's move on to ordinal level variables, where the numbers designated do not have a mathematical property to them. However, you can rank order the numbers, such as scores on an attitude test, or let's just say rank or standing at the university. You could be a freshman, a sophomore, a junior, or a senior. Now, you can rank order them as a person further along in their education, and of course, a senior would be ranked number 4, where a person ranked lowest would be ranked number 1. But at the same time, it doesn't designate a particular, say, year, which might be a common mistake, because an individual could take more than 1 year to jump from freshman to their sophomore year, or junior to their senior year for that matter. So you can rank order them, and the way to do it would be 1, 2, 3, 4, with freshmen being at number 1 and seniors being number 4, or vice versa. But there is no mathematical property, meaning you cannot say a senior minus a freshman equals 2, meaning 4, or 3 rather, 4 minus 1 equals 3. That's not how it works. It's just designating a particular category where those categories can be ranked. Then we have interval level variables. Interval level variables, or interval level measures, do have mathematical properties to them, and they can be rank ordered. The issue is that interval level variables have no true zero. A zero indicating nothing, essentially. So why that's important is that in certain things, such as outside temperature, or say standardized test scores like IQ, 0, or say within temperature, you can't have no temperature. Yes, we do have 0 degrees, but 0 degrees in Fahrenheit just means very cold. 0 degrees in Celsius just means the freezing point, where, incidentally, we use the Fahrenheit scale here in the United States, and 32 is our freezing point, which may seem odd. So, in the end, there is no true zero. Standardized test score like IQ, you cannot have an IQ of 0. So, with that, not having a true zero, we can't complete ratios. For example, 40 degrees is not twice the degrees or twice the temperature as 20 degrees, nor is 20 degrees half or 50% of 40 degrees. We may think of it that way, but mathematically that is incorrect. At the same time, you can do the math on it. 40 is 20 degrees higher than 20 degrees. Or 20 degrees is 20 degrees lower than 40 degrees. So you can do the math, you just can't do the ratios on those particular variables. The highest level of measure is, of course, ratio, where you can rank order. There is a true zero, which means you can do ratios, and there is a mathematical property to them. So, for example, age. A person who is 40 degrees is twice as old as a person that is 20 years old. Did I say 40 years? So, a person that is 40 years old is twice as old as a person that is 20 years old. Because there is a true zero. There are babies that are 0 years old. So, that's how you have to think about the 4 levels of measurement. Nominal level measures have no mathematical property, no true zero, nor can you rank order. Ordinal level variables, you can rank order them, but there is no true zero, nor does it have a mathematical property. Interval level variables, you can rank order them, you can do math with them, but you cannot, there is no true zero, so there is no rank, or there is no doing ratios with them. And of course, ratio measures have all those qualities where you can rank order, you can do math, meaning there's a mathematical property, and there's a true zero. Subsequently, you can make ratios, such as one thing is 50% higher than another thing, so forth and so on. So that is just a brief overview of our levels of measurement, and that's what we're tackling here in our assignment. So when you look at these variables, and the variables are across the line, so we have 6 variables, one of them being prison ID, the next being race, then age, prior felonies, IQ, and victimization likelihood. So, moving through our questions, what is our sample size? Calculating our sample size is pretty simple. It is just counting the number of observations we have. With this, we have 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Our sample size is 11. Incidentally, based on our question up here, we know that our unit of analysis is inmate. Assuming that you understood that prison ID represented an inmate. So that's what's actually being studied. So here we go. The variable is prisoner ID. Our dependent variable, as we discussed previously, is victimization likelihood. And our independent variables are the other 4 variables: age, prior felonies, IQ, and race. So what are the levels of measurement for each data set? Or for each variable, rather. It is, bear with me here. Prison ID, as we've already said, was nominal. Can't rank order those numbers. They have no mathematical property, nor can you complete ratios with them. Race the same way. You cannot rank order race, nor does it have mathematical properties, nor a true 0 point. Age, on the other hand, we see up here in the data set that we have an age variable. Age, you can rank order age from highest to lowest or lowest to highest. They do have a mathematical property, meaning someone who is 27 years old is in fact 8 years older than somebody that is 19. And there is a true 0. There exists people that are 0 years of age, babies, of course. So a person who, again, is 40 years old is twice as old as an individual who is 20 years old. So age is a ratio level variable. Prior felonies, I believe, is the next one on our sheet. So let me scroll down. It is also a ratio level variable in this instance, as these is what we call a count variable. Inmate 63412 has 1 prior felony, whereas 63561 has no prior felonies. So there is a true 0. Someone can have no prior felonies. So you can rank order, mathematical property, and there's a true 0. We've already covered the idea of intelligence quotient. This is an interval level variable or measure, because you can rank order them from lowest to highest, highest to lowest. You can do math on them, meaning an individual with a IQ of 101 has an IQ 18 points less than an individual with 119. But at the same time, there is no true 0. And lastly, victimization likelihood, and here's the big clue, is an ordinal level variable. You can rank order an individual's victimization likelihood, as we have. The likelihood of being a victim while in prison is more so for an individual with 3 than an individual with a 1. So we can rank order them, but you can't do math on them. There's no way to do a math on a person who is likely compared to an individual who is not likely. So you just have to think of these numbers as categories.